Now heading towards the electromagnetic plane waves. The plane electromagnetic waves can be expressed as that. In previous term, is the equation. Just put this relationship here. We get this equation, where n is a polarization vector. Then this is another vector that came forward to it, that is polarization vector. Okay. Now the real electric and magnetic fields in a monochromatic plane wave with propagation vector k and polarization n vector are therefore, that is a phasor form, propagation vector form, vectorical format. The plane waves can be written as like this, a cosinusoidal equation. Now, what is polarization? It is a very important part. The polarization is specified by the orientation of the electromagnetic field. The plane containing the electric field is called the plane of polarization. The plane containing the electric field is called the plane of polarization. Okay, you can see this. A polarized wave, E field and H field, each oscillate in a single plane. Just look at it. If it is magnetic field here, there is an electric field here, and this electric field is like a sinusoidal waveform, cosinusoidal waveform, like that. Okay, like that. Okay, and there is another wave of magnetic field is also a cosinusoidal waveform, like that. Both are perpendicular to each other. Okay, you can see here there is the plane, that is a perpendicular plane here, okay, to each other. Again I will show you, that is the path of E. So E will propagate like this. The plane, that this plane is perpendicular to it, and the magnetic field will propagate like this, longitudinally. Okay, when there is electric field on that direction. Okay, so the polarization will come beyond this, that means the propagation direction. Okay, direction of propagation, both things. The plane containing the electric field, this plane that containing the electric field is known as polarization. Now that is the polarization, that is you can get a better understanding here. There the plane go through to it, there is longitudinally, there is a yellow part, electric field, and the direction of polarization is like that. If the electric field in vertical polarization means 90 degree to at perpendicular, vertical polarization. If the electric field just go through to the surface area, that means horizontal polarization. There is circular polarization. There are a lot of polarizations. Circular polarization, it is this polarization creates a circle to it, so it is circular polarization. Now, energy and momentum of electromagnetic waves. The energy per unit volume stored in electric field is like that. That is the equation. In the case of monochromatic plane wave, monochromatic means the plane wave is a single light or a single frequency that generates a single frequency, okay, or single wavelength. That is known as monochromatic plane wave. You can write through like this. That I have told you before, B cross E is equal to 1 by C cross K cross E. B vector is equal to like that. I have told you before. And the last of all, as the wave propagates, it carries this energy along with it. The energy flux density, energy per unit area per unit time transported by the field is given by Poynting vector. That is known as Poynting vector. The monochromatic plane wave of Poynting vector is like that. Thanks to all for being with me. That is the last lecture of electromagnetics. I hope you do understand better, but there are some complex issues in electromagnetic wave that are very hard to know, and you need to study hard to understand this. But till then, I try my best to give you some knowledge out of it. Thank you very much for being with me.